My desk has descended into chaos. But we shall find order in that chaos in this box. It was just dropped off a couple minutes ago. I have not opened it yet. I have simply slit the tape. So you will get the Ubi, that will be out-of-box experience with me, as we take a look at, dun dun dun, the Amazon commercial, heavy duty, 50,000 count, digital multimeter. Special effects now, high class. So this guy sells for 150 bucks on Amazon. You get some test leads, charging device because it has an internal rechargeable battery, thermocouple connector, for charging, I guess. We'll have to read that. K-type thermocouple, rechargeable battery, and the meter. That's nice. So the model number on this is 90DM890, and for a size comparison, there it is next to a standard size fluke meter. Hold on a second. You can see it's about 3/8 of an inch shorter, width-wise about the same, and slightly thicker. We like them thick around here. This charging adapter is interesting. Plugs in here. We take a look at the back of it. It has this groove that locks your selector switch in the off position, and then you simply plug in right there. It's got a nice rubbery condom on it, Phillips screws, Intertech, UL listed, and Cat 4 600 volt, Cat 3 1000 volts, and I think I actually believe this one. Simple lock slash unlock thingy here. So now it's unlocked. Oh, that's too small. That's not the right kind of screwdriver. One moment. Perhaps we can spudge it open. Again, no. Well, crap. I had a flathead screwdriver around here somewhere, but I cannot find it, Captain. How about a machinist square? Yes. Machinist square will do. Will it? Yes. Okay. So there's our battery compartment. There we have a 10 amp 1000 volt ceramic sand filled fuse, and underneath it there is another fuse, and we'll get to that when we tear her apart. Here's our battery, lithium polymer, 1200 milliamp hour, 7.4 volt, 8.8 watt hours. Let's turn it on. That is a nice looking screen, and it is a color. TFT LCD, and the battery is fully charged. Here you can see our specifications. I'm not going to go over all this with you. You can pause it and read it to your heart's content. Just want to get to the page here. Our fuses. Fuse 1 is 0.8 amp, 1000 volt ceramic fast flow. Fuse 2, 10 amp, 1000 volt ceramic fast flow. Display 50,000 counts. Measurement rate 20 readings per second. Peak capture is greater than a millisecond. Input impedance DC is 10 mega ohms, 9 mega ohms. For AC response is true RMS. AC voltage bandwidth 50 hertz to 20 kilohertz. Wow. Temperatures, humidity. Dimensions are 3.15 inches by 2 inches by 6.88, or 80 by 51 by 175 millimeters, and it weighs 0.93 pounds. So yeah, it's a chunky little guy. Let's get to some testing. All right, as is our tradition here, we will be using the very nice ProbeMaster probes when we test multimeters. We use them when we test all meters. That way, we eliminate the variable of different quality of probes and leads from the equation. So let's go DC voltage. And we have our voltage standard here, which has been warming up for a little bit. Clip our leads on there like so. And at our 2.5 volts, we are reading 2.5052. At the 5 volt range, 5.013. You can see that nice little thing there as well. Little bar graph. 7.5 volts. Dead nuts, 7.5. Well, now it dropped 7.499, but hey, close enough, right? And 10 volts reads 10.006. So, as you would expect from a meter in this price range, it seems to be right on the money. So what I want to do now is have a look at the graphing feature, or the trend feature, as they call it. We're going to use our bench power supply here. I'm just going to hook our leads right to it. And if I press the F1 button, we get this nice graph, which I'm going to zoom in so you can see. And then I will bring it in there. Okay. So now if we bring up some voltage, we'll hit start. Okay, so I'm showing 1.2 volts on the bench power supply. This is showing us 1.31 and some change, and that's okay, because I certainly expect this to be more accurate than the bench power supply. Alright, I'm going to slowly ramp the voltage up. Take it up, say, let's say around 5 volts. You can see we're now reading 4.98, yeah, 5 volts. Alright, let's take it up some more, say to 10 volts. Now we're at 10 volts. And you can see how the graph automatically adjusted for the range. Let's go a sharp rise to 15 volts. You can see the little sharp spike right there. Now let's jam it to full power, which is 30.4 volts on here. Very nice. Then let's go down. There's 3.5 volts. Then we'll go up. down and up and down. Then we'll take it all the way down to 0 volts, or as close to it as we can get with this power supply. 0.8, 7, 6, 5, 4, 3, 2, 1, and that's as low as we can go. And it's reading 0.05 volts. Yeah. This graphing feature is quite nice. Now, what we can do is we can actually save that feature and recall it later. That is super nice. Let's go and check out how it does with resistances next. Alright, for resistances, we are going to use this little decade resistance board. You can get them from Amazon. They are available in my store, like $9. We'll clip our leads on here. One high, one low, so we don't get a short. And we'll put this guy on resistance. And let's start with 10 ohms. Yeah, 10.3. How about 90 ohms? Close enough. How about 500 ohms? Yeah, that's quick. It's right on. 900 ohms. .897. That's close enough to 0.9 for me. 1K. $1,700 or 7K, 6.98. Alright, how about 500K or 50K? Yeah, that's 10K I'm on. Okay, good. 50K looks good. There we go. There's 500K. Right on. And how about a meg? Close enough. How about 9 megs? Let's ramp it up. What I'm going to do now, bring all these up here to their highest point. Except for the single digit ohms. I don't really care about that. So we should be right below 10 megs here. Not bad at all, and it's pretty quick, and has the nice bar graph feature as well. What should we check next? Capacitors? Or oh, I know what we should check next. Why don't we check continuity? Let's see. How do we switch to continuity mode? There we go, continuity mode. It's not super quick, but it is quick enough and accurate enough for our purposes. All right, let's check some diodes. I just happen to have some sitting here and waiting for us to take a look at. So we will adjust our mode to diode mode. Then we have our board here with some diodes. First one we'll check is a standard silicon junction diode, which should give us a forward voltage of between, 0.5 and 0.7. There we are, 0.6169. Let me adjust this here a little bit so you guys get a better view of what's happening. Alright, need a little prop job there, right? Okay. So next up we have a Schottky diode, which should come out around, between 0.2 and 0.3, right? 0.19, alright. Close enough. Now let's take a look at some LEDs, which are of course diodes. Depending on the voltage it uses to measure the diodes, we should be able to light, the diodes going up. As we go up, we're going through higher voltages. So the red should light no problem, and it does, and it shows us forward voltage. Then the yellow lights shows us forward voltage. The white, forward voltage. The green lights, and you can see the forward voltage. Same with the blue. So, works really well there. Also has a max hold function. Nice. Let's go next to capacitance. Alright, our first contestant will be this lovely little chocolate drop. 3005%. This is a 500 volt capacitor. Let's see how she reads it. 3 nanofarad. Heck yeah. Here's some little dinky doos. I can't even read what they say on them. $16. Let's see if we can make it out. Hold on. Got sneeze. Sorry, I had to sneeze. Let's see if we can make out the markings on them. I cannot. This may require the assistance of the head visor of wisdom and knowledge. Wow. They are marked 15.3, so we were getting 16, so that's not bad at all. Not bad at all. Let's see if we got some bigger ones around. Alright, I got us some random capacitors to have a look at. These ones are 4.7. These, of course, are polarized, so we just got to be a little careful. Reading 4.1. As far as capacitors go, that's actually pretty good, right? Here's a nice axial capacitor. I was going to say 10 nanofarad or 10 microfarad. Yeah, 10 micro at 16 volt. Let's see what we get out of him. Or her. I'm not judging. Not assuming. 11? Sure. Sure. What do we have here? 22 microfarads. Clipper in there. Come on, there you go. $19.8, close enough to 20, which is close enough to 22. And then just for shits and giggles, here's 10,000 microfarad, which I just discharged. And now we shall charge her up and see what happens, right? Thinking, 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 thinking. Come on. 8.53. Alright. I am good with that. We say we take a look at some AC voltages next. Okay, so I got her plugged into the wall there. We could even bring up a graph and graph our AC voltages. How about that? Let me fix the light here. There we go. As you can see, it is not changing very much. Put it in fast mode. Give it another shot and see what we get now. Yep, still staying pretty flat there. No worries. We change the nope. Won't let me change the range. Okay. So we look at frequency. Alright. Get the screws out of her. You don't need to watch that, do you? Okay, screws are out. There were 2 up here, 2 in there. There we go. And now, for the part we've all been waiting for. Let's have a look at its gazindas. Let's zoom in here. Okay, so we have our input jacks. There's our current shunt. I think that's a ferrite. Interesting. We have our low current fuse under this little cover here. There we go. Then our high current fuse we can adjust from the out or replace from the outside. We got 6 diodes there, 7. Nice big resistor there. We have some melts over here, another diode. We've got a MOV hiding back there, along with a ceramic resistor pack. We've got 2 ICs. Let's see what that says. That HY, I'm gonna hazard a guess, is the display driver, and the Texas Instruments would be the main processor. It's not too shabby. It is much better than your average Chinese meter, which I would demand from a $150 meter. It is nowhere near a fluke. But it's not bad. Like I said, it's definitely better than your average Chinese meter. The case construction is thick plastic, and it does nestle here very nicely for explosion protection for the user. So you can see how that kind of all goes together like that to keep you safe. This is an incredibly nice meter, and you know, you're paying for an incredibly nice meter, so don't accept anything less. The protection seems quite adequate. Again, it's no fluke, but it's 10 times better than your average Chinese meter. Alright, let's check some current. My little current generator has decided to stop working. I don't know what's going on. Like it'll put out a pulse, and that's it. I'm going to have to figure out another way to measure some current. Okay, I'm not getting anything off my second current generator either. So I'm just going to check the fuses. That one's fine. That one's fine. I am very confused now. I was afraid that the meter was bad, but it's not. Here is another meter. And again, this is set for 20 milliamps maximum output. I got this set for as high as 60 milliamps. Jacks are in the right place. Nothing. Both my little current generators have crapped out on me. Well, that sucks. What's a boy to do? Well, I bet you we can read some AC current. We can read DC current with this too, but I don't know how accurate it'll be. Let's try some AC current. So, let me put the meter. Yeah, I'll be right back. Well, it would appear to be faulty. A big old flop. I've tried everything. I can't get it to read any current. This is unfortunate. I'm going to try one more thing. Yeah, just a last-ditch effort to see if I'm doing something wrong. There we go. Got it working. I'm using an incandescent bulb. I'm not touching anything because the the setup here. There's the incandescent bulb. There is the precarious setup. Definitely don't want to lick that. But yeah, she's working. I just wasn't smart enough to figure it out. Had to RTFM, you know how that goes. Anyway, again we have the whoops, I hit the wrong button. We have the graphing mode here as well. As you can maybe see. Oh, come on. Hang on. Sorry about the difficulties. The thing is, there you go. You can see the graph. I mean, nothing's really changing there, so we're all good. But I said, sorry about the difficulty. This thing's matte black. It's hard to light. If I get enough light on to light the case, then it overpowers the screen. But it's all good. It is an interesting meter. Let's take a look at the charging and we'll get out of here. So to charge, we have this adapter, 10 volt, 1000 milliamps. You could have just wrote an amp on there, you know. You can plug in a extension cord here. Something just fell. So we plug that into there. Plug our charging adapter into there. That plugs in like that. And you can see we get a battery charging indication. Overall, it's a very nice meter. It is slightly complicated to use. Doesn't mean you can't use it, but you are going to need to RTFM. That's a hard pill to swallow as a man, I know, but sometimes you have to. Anyway, that's it. I hope you guys enjoyed this video. I'll put the link to this in my store. Please give me a thumbs up. Feel free to comment, share. Don't forget to subscribe. Big thanks to all the patrons. Big thanks to you, right there. You, for watching the videos. Wouldn't be here without you. That's it. I'm out. Peace. I want to thank you all for watching and spending time with me today. A community like this is something that we can all be very proud of. So again, thank you very much for all your support of Learn Electronics. Please feel free to check out the Patreon page. $1 a month is all I ask, and really helps keep the channel alive. We also have an Amazon shop where you can buy most of the items that you see on here, and there's a link to it down below.